All right, good afternoon and hello everyone. My name is Mark Baggett. I am a senior instructor for SANS, and here I am I'm here today to present to you the Hacker's Guide to Environmental Catastrophe. You see my Twitter handle, my email there on the slide if you'd like to reach out to me. Just a little bit about me, my background. I do penetration testing, incident response, consulting. I'm a senior instructor for SANS. I'm the course author for SEC573, which is Automating Information Security with Python, and the soon-to-be released SEC673, which is an advanced version of Automating Information Security. Also working on another course that I'm co-authoring with two other SANS instructors called SEC406, which is an introduction to Linux security. And I'll give you a little bit of a preview of one of the labs from that, which is very related to what we're talking about today at the end of this presentation. Couple other things about me. I got my GSE number 15. If you're in the Augusta, Georgia area, then you'll be familiar with B-Sides Augusta and the Greater Augusta ISSA. I was the founder of those. And I'm the author of a couple of Python tools that some of you may use. StrumDump's a very popular forensics tool, Freak.py, Domain Stats, and there's a couple of others that are out there. Let's see. Last thing I'll mention is this thing down here at the bottom. If you were to go into the Metasploits framework, Metasploit, the open source exploitation framework, and you were to grep for my name, you'd find that, well, my name appears in the source code for Metasploit actually 7 times. I haven't actually written anything in the Metasploit framework, but other tool developers were kind enough in writing their tools to give me credit for research I had done in the tools, the techniques and procedures that those tools had implemented. So that's a little bit about me. So this presentation today really started from this tweet that you see here on the screen. Went onto Twitter and I saw this thing. It said, "I'd like to thank whoever decided it was cool to stuff secrets and passwords and tokens and stuff into environment variables. It makes hacking stuff so much easier." And there is a lot of truth to this slide. And I thought about it and I was like, and it turned out that I had just been doing some things in one of my engagements that I ran into some trouble in getting information out of some of these environment variables. And so I just posted the question, I'm like, so what did you use to grab the environment variables on there? And their answer was, well, I used env or set to get those things. And I was like, okay, well, that completely different situation. So I thought it would be good to go through and just talk about how we secure environment variables, what it is that, what situations they are just readily accessible to attackers who are breaking into systems, and other situations where attackers might have some levels of access and be able to get to those things and where they can't. So first, let's just talk about what the problem is. As we move more and more things to the cloud, right? If you've done anything with any type of automatic AWS configurations or Azure or just about anything where you've got cloud-based services, it's not uncommon that the way that you go before you run those tools, you configure a lot of environment variables with sensitive data like access keys and secret access keys, right? Your API tokens that you've got associated with these. If we're talking about web frameworks, so popular web frameworks like Django is one that you see here. Here's a little bit of code from Django. This is Python code. And in this Python code, you can see they're calling os.environGet to extract or to pull an environment variable into the program so that they can see how is it that you want this application to run. And you can see that there's all kinds of information, application secrets, there's the database engine, the names of the database users, the database passwords, host passwords. There's all kinds of sensitive data that more and more often we are configuring in environment variables for our applications to use in order to run. So let's talk about environment variables, the different kinds of environment variables, how we would secure them, and then what access those attackers would have. First, let me clear up the difference between local environment variables or shell environment variables would be another way that you could refer to these, and environment variables, things that we would use to configure systems. And to do this, I think even though I took all the time to write these slides and colorize the things input and output, I think it's just better to demo these things. I prefer demos over slides. So let's just say I want to create an environment variable, API key, right? My API key is equal to some secret. Okay. So I've now created that environment variable API key. Now, in creating environment variables, you just use the name. When you want to retrieve that, say like you wanted to look at it, you could use echo, and then you put a $ in front of it when you're just going to look at it, API key. So that shows me my API key. Now, this API key is actually only available in this exact shell, this bash prompt that I'm sitting at right now. If I was to open up any other process, or even if I was to run a program in this shell, the program that I run wouldn't be able to see that key. Just to give you an example of that, let's just launch a new bash prompt, and then in this bash prompt, I'm going to just run a command. I'm going to run echo $API key. All right, so I'm going to echo that key. The same thing I just did in this bash prompt, start a new bash prompt, and then show me the key. And well, no, wait a minute. It is there. What's going on here? Bash. Okay, echo $API key. All right, it is not there. So this is in a sub process, right? I've launched a new process here called bash, and then if I try and look for it, it's not there. All right, so now I'm going to go back to the bash process that I was in. So now if I echo $API key, okay, it is here. So in this process, it was there, but when I go in a sub process, it's not. Another way you can see that is there's two commands you can use to show you all the environment variables. One of them is set. So if I run set and I look for API key, the set command will show me, yep, there it is. So that environment variable has been created. Another command that you can use to look at your environment variables is env. You'll notice that when I do env, it does not find that API key. So this, when an environment variable shows up in set, but not in env, it is only accessible to that process itself. So then the question becomes, all right, how do I make my environment variable accessible to programs that I run inside of this shell, right? When I launch a new process, a Python program, a web framework, something like that, how does it get access to be able to read this new API key? Well, that's what you use export for. So if I say export here, API key, well, now that environment variable has been exported and it's available to sub-processes, which means if I run my set, it's there. And now if I run env, env, it's also there, right? So it's showing up in both of those. Just to confirm what we do, let's also launch a new bash prompt here and then echo $API key. Right, and you can see that it is now available in this sub-process, this bash sub-process from there. Okay, so that's the two different kinds of environment variables that we can have. You've got the ones that are just local and the ones that you can export. Now, if it's just a local environment variable, it's really only good for like bash scripting, right? A bash script might set an variable and then check it. But that really can't be used to configure other applications because it's not available to any other applications. You have to export it before it becomes available to other applications. Okay, so those are our two types of variables. Let's just look at my slides, make sure I'm not reviewing anything, forgetting anything I wanted to mention. So we got our local environment variables. If you just create one like this, it's local. And you can use it within that process. It shows up in set, but not in env. If a new process was to try and access it, it would not see it. So here it's in set, it's not in env. It is available to the current process, but when we run a new process there, oh, you know why? The single quotes. I know why my bash command. Just a side note here. When I did this bash prompt earlier, I used double quotes. If you use double quotes at the bash command line, well, then actually this shell will expand variables inside of the double quotes. If you use single quotes inside of at the bash command line, then the shell that you're currently in does not expand the environment variables that you have inside of the single quotes. It passes that entire command onto the new bash prompt. So, well, now I've exported it. So I could unset it, but Yeah, you know, all right. So that was why that didn't work earlier. But you can see here that when I use the single quotes, that the environment variable does not appear in subprocesses. When I want to show it in subprocesses, I have to export it, right? Exporting it makes it available to subprocesses. And you can confirm that by looking in your env command and see, does the environment variable show there? And then yes, now it is available in those subprocesses. Okay. So who can see environment variables? If it's not exported, then it's only the process that set the environment variable, which we'll call the parent process. It would not be available to any web frameworks that you launch from that process or any child processes of that web framework. If you export the environment variable, then, well, it's available in the shell that created the environment variable. It's available in, say, the web framework that you launch from that shell, and it's available in all of the child processes. So that's a whole lot of places that it is accessible. And maybe I could reduce that a little bit. One thing I could do is if I want to make a variable available to a child process, but not available to my process, right? The fewer places I can store these environment variables with all of these API keys, the better off I am. If I want something to not be available to my process, but to be available to the child process, then you can set environment variables on the command line here. So I could, so here, let's echo mark, the environment variable mark. So there is no environment variable mark in my subprocess. If I wanted to set that though, I could say mark equals hello, and then run that other command, bash -c echo $mark. Okay. And now you can see that variable mark was available in the sub process, but I didn't actually create that environment variable in this shell that you currently see on the screen. So if I echo $mark here, it doesn't exist, right? So this is one thing I could do in order to reduce where my environment variables are set is, well, don't set them on separate commands, right? Instead, just set your environment variable, have a space, and then, well, put whatever else you wanted, whatever command you were going to run that's going to use that. And this just makes this available to the child process of that bash prompt and not to the current process, the parent. And that's interesting. It's one thing I could do, but with all of these environment variables that I'm setting here, I've got another problem, and that is, well, it still shows up in the history, right? If I type history, I can see all the commands I've typed, and guess what? There's my API secret key. Here's my API secrets, right? So it's just in my history. Now, there is a very easy way, if you're ever typing passwords, usernames and passwords, or command lines where you're passing, SSH credentials on your command line, you don't want that stuff in your history. Then a very easy way to prevent things from showing up in your history is when you run a command, put a space at the beginning of it. So if I just put a space here, and let's just change that to something other than hello. Let's run it once with hello, and then let's run it. I run it once with hello and no space, and then I'll run it once again with a space and goodbye, or just bye, because I'm a lazy typer. Now, if I look at my history, you'll see that hello shows up in the history because it did not have a space, but bye does not. So that's one thing I can do to keep that out of my history, is to keep just put a space at the beginning of your commands in bash. And then by default on most systems, that will ignore that command. It executes the command, but it doesn't record the command into your history. So that's a nice little step you can take. Now, and here's showing that. So here, if I export an API key and then I run history, I can see that, well, that API key is in my history. So if I just put a space in front of it, now it's not going to show up in my history any longer. Now, that setting of whether or not it records things in your history is actually stored or controlled by an environment variable. There is the hist control environment variable. And that hist control could be set to a couple of different things. If it's set to ignore both, then that means that, yep, it is going to ignore commands that have a space in front of it. The other options are, well, ignore dupes, which says if I type the same command twice, only record it in history once. Ignore space, which says if I have a space in front of it, then ignore the command, or ignore both, which says it ignores dupes and spaces. So you can check that hist control and see if it says ignore both or ignore space. And then you can use that, or you could just, well, check your things. But that's a step we can do to also prevent environment variables and any kind of sensitive data, not just environment variables, from being recorded in our history files. All right, so let's look at a couple of scenarios of once I've created these environment variables, how attackers could steal these environment variables and what is exposed to them. All right, so in order to do this, let's first look at a web server that has a code injection vulnerability and whether or not that is accessible to it. So over here, I've got a little tool called APIify. And what APIify does, let me just launch Visual Studio Code and show you a little bit about APIify. APIify is a tool that I wrote that you can take any Linux command, basically, and you can have that Linux command execute, and then this will turn it into a JSON output. So I use this for things like Elastic or other types of event management platforms where I have some value like an IP address or something, and I want to run a Linux command like an NSLOOKUP or a trace route or make an API request to look up its geolocation information, but I get that stuff back as a JSON response. So the way that APIify works is you just have this little configuration file, so this YAML. It tells it how many entries that you want to cache. So once it's looked up an IP address once, it'll continue to cache this thing. This will respond at about, I think I've been told that it's been tracked at like 30,000 requests per second. So it's been written for speed so that it will keep up with your event management platforms. Here you can see that I've got this option to block command injection attacks. By default, that's turned on. This is actually the whole reason I'm showing you the setting, is so that you don't think that this is a horrible, vulnerable application. I have gone in and turned this setting off to make it so this tool can be, so that I can have a command injection attack into this tool. Okay. You can also turn on debug statements. And at the moment, I've got it configured just to run a ping. So whatever information I pass on the URL is going to replace this variable called web info. So it's just going to ping something one time. So if I was now open up a web browser and I go to 127.0.0.1 port 8000, where I'm going to run APIify, let's come over here and run it. Python APIify. I don't want to load the cache. All right, so now it's running, and it's going to run a ping with web info. If I was to make this web request here, ping something, you can see that it runs the ping command. I hope 127.0.0.1 port 8000 runs the ping command. There, I get back the ping, and it gives me back the response here into the website. Okay, so it responds there and gives me back the response. Now, rather than doing it here in this web entry, boy, that's running slow. Rather than using the web to do it, I'm going to use wget over here to do these things because it's easier to see on the screen. All right, so I could say, wget pinggoogle.com. And so this will make a request over here to my APIify, which again seems to be running slow. I don't know if I must have something else consuming a lot of my CPU resources here. I hope it's not my internet. Am I still online? Let's see here. All right, I am. I'm still good. Let's see. Why is it taking so long? Let's not do DNS. Let's just try 8.8.8.8. Okay. All right, that came back. That gave me that cache response. Now let's try and put a semicolon here and put a second command at the end of that, like the ID command. Okay, so that should send off this request. APIify is, what is this thing doing? Okay. Oh my goodness. It's because I have it in the, I don't have it here. Just close down some things. All right, there we go. I have a limited amount of memory, so I had to close down the Visual Studio Code here for this to go. All right, so that gave me back the ID command, right? Here you can see at the bottom, I've got this ID command that also ran with my API-FI. So now, since I've got this code injection vulnerability, let's set an environment variable over here in this shell. Let's actually say API secret equals blah, blah, blah. Okay. And then I'm going to, let's export it so it's available to my API-FI when I run it here. Okay. And let's type env pipe grep for API and see if it's there. Yep, it's there. So it's exported. So that means the sub process that I run, which is going to be API-FI. No, don't load the cache. All right, so it should be able to see that environment variable. So now over here, let's run the command set pipe, or let's do env pipe grep for API. All right, we send off our web request, and man, what is it? What do I got? What else have I got going on here? All right, it's taken a little bit of time there. I'm not sure why. I've got something else that's consuming my CPU here. But here you can see that I got back that environment variable. So that environment variable, if you have a code injection vulnerability in a website, the attackers will be able to use that and gain access to all of those API keys and other things that you've set up for those environment variables. So in that case, any type of code injection vulnerability, it's very, very trivial to gain access to those environment variables. But the situation I was in that caused me to ask the question that said, wait a minute, how are you doing that, was a little bit different than this. I didn't have a code injection vulnerability. I was actually trying to get to it as a server. So code injection vulnerability, yeah, they're gonna be on there. But what if, let's say, I was on the web server, right? I had guessed a username and a password. The attacker does it in my particular case. The web server was also running an FTP server and an SSH server. Through the FTP server, I was able to find some passwords actually that were in the FTP account. Then I was able to SSH in. I was now on the box as another user on that system, and I wanted those API keys that were being used by the web service running on that same system. So now there's no remote code execution. Can I still get to those environment variables? And the answer is, well, yes. Obviously, if I have all the permissions, like root permissions, then I can dump memory. I can gain access to anything if I'm root. But what if I'm another non-privileged, non-root user on there? Can I gain access to those environment variables? And that's the situation I was in. So to answer that question, let's talk about the first place I went, right? The first place I went is to the proc directory. So over here, let's see, let's look at PSAUX or PSAU and PSAUX. Oh gosh, let's make that smaller so I can see it. PSAU. And here I can see that my API-FI command, here I'll make that a little bit bigger so you can see it. My API command is running in process 92916. So on a Linux system, when you start a new process, there's top, that was probably taking some resources. There is a directory that's created under /proc for each and every process. And one of those will be in here. It'll be 92916 or whatever my process ID number was. What was it? It was 92916. So back over here, let's CD into 92916. Right? And in here, if I do an ls, I can see all of the different things that it recorded when it started this process. One of the things that it records here is environs. And guess what that is? That is your environment variables. And this is, I can just cat this. Okay. And if I look through here, down here at the bottom, API secret equals blah, 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 blah. So there's my API secrets. So if you can access the proc folder, I can get to these. Now the question becomes, who can access the proc folder? The answer is the people that can access this proc folder are obviously the root user, but also the user that started the process. So for example, if your web server is running under, web login, the account web login, if in my situation, if I SSH'd in and I was the web login user, then I could gain access to this proc folder, go into the proc folder, and I would be able to see these environment variables here. Or at least I should be able to see the environment variables here if I am either the root user or the user who started the process, then I would be able to see them. But what I found is for some reason, I can't see these. The variables weren't there, even though I should be able to see them. So there was something else that was going on with this web process. And I was like, why can't I see these API keys? I want to see these API keys. And so as it turns out, there is something that you can do to make it so that those things aren't available. So the proc folder only records the environment variables as they are set when the process starts. So if a process was to, start a process, say after something had already started, then it wouldn't be set. So let's come over here. I think on my desktop, on my desktop, I have something called set variable after it loads. All right, so in this little program here, it's just going to import the OS module, and then I'm going to create this variable called setup after load, and I'm going to set it to more secure, and then I'm just going to sit there in a while loop and print this thing. So let's go ahead and run this thing. Python set up variable after it loads. All right. So now that environment variable has been placed in memory for this process, and you can see it's echoing it over and over and over again. Can I gain access to that through proc? So let's come back over here. Let's do a PS, or actually let's do this just as a student user first. Let's do a PS AU. And all right, here's my process ID number 92945. Let's go ahead and change into that directory. And cd ... cd. See, the process that I was in went away, so I can't change out of it. Cd paste. All right, and then cat environs. There's my API secret. Wait a minute. Is API? Oh, because I exported it in the other one. There's my API secret. I don't see the other one. Just to be sure, let's pipe that and grep for the name of the environment variable, which I've forgotten. What was it called? It was called setup after load. All right, so let's just make sure grep for setup. Nope, it's not in there. So if a process creates environment variables after the process is already loaded, then it does not show up in proc, which, okay, that's a different level of security, right? That is improving that security where even if I get onto this process and I am the user that created the process or root, then I cannot look inside of this proc folder and gain access to those environment variables. So I think, okay, that's good to know. That is useful information in trying to protect those API keys. But are there other ways to get this information? Well, let's see. All right, here's the process. This slide is showing you what I just showed you in the demo. So over here, I create this API key. I then look at my process number, which is 62506. I export it, and I come over here and just looking for that. I can't find the API key. If after I've started the process, if once you start a process, that's the only time it records this proc environment. It does not update that information as the process is running and its new environment variables are created, which means if instead of setting environment variables and then launching my processes, if I had those in a secure configuration, like in an encrypted file, and then the process itself set the environment variables when it launched, then, well, that would that would actually provide some security benefit to these. But I can still steal them from memory. Okay. So I wrote this little tool in order to try and solve this problem when I was doing it. You can get this off of my gist, right? I know you're not going to remember this, and it's such a pain to type. Let me just show you a better way of finding that. So if you just go to gist.github.com/Mark Baggett, and I'm going to be logged in, so it's going to show you all of my private gists here as well. But if you look, there you go. On there's one called dump process variables. It's just a single script, so I didn't bother putting it on my GitHub where I put all the packages and things like that I maintain. So this script is there if you want access to it. And let me just show you what this thing does. All right, so I cannot gain access to that process via cat environs, but is it still running? I can get access to it in another way. So if I run my Python program, Python home student, it's on my desktop, and I call it dump something or other. And then I need that process ID number, which, let me scroll back up, 92945. 92945. What this is going to do is it's going to attach the debugger to that process. It's going to search through memory, and it's going to look for environment variables. And here you can see, all right, there it is. So I can still gain access to those processes if I have the ability to dump memory from the process, obviously. And obviously root is going to have access to do that. So then the question becomes, well, who else could do this? In my case, I was running as the web service account, right? The same account that was running the web server. And I could not dump the processes. So I was like, wow, that's interesting. What does it actually take to be able to dump these processes? And so as I looked into it, this is what I discovered, and passing this on to you. In order to be able to dump the memory on the process, only the root user can do that. And the user who launched the process might be able to dump them. The way that it works is the user who dumped the process can dump his own child processes, but he can't dump sibling processes. In other words, if user student launches process 1 and then user student launches process 2, which is not a child process of process 1, it's just a second process that they've run. From within process 2, I could dump the memory of any child processes of process 2, but I can't dump the process memory from process 1 unless I'm a child process of, or actually I'm a parent process of process 1. Only the parent processes can do this. So it's actually a good level of protection. Now, this is actually a setting that is in the machine in your file called etc system control 10ptrace.conf. There's a setting in there that's either a 0 or 1. If it's 1 or one of those options, 0 or 1, you can, as the owner of the process, dump sibling processes, and in the other, the default setting, you can't dump your sibling processes. So even if I was logged in as the web server, I can't dump the memory from that. And I was like, oh, that's actually a pretty good security. So if the environment variables weren't in proc and they weren't in history, and I don't have a command injection vulnerability, then I cannot get to those environment variables easily, right? Can I get to them? Well, I'm going to need to gain access to root, and I'm going to need to circumvent these controls in order to be able to get to that system. So the answer is put all of our environment variables into config files, and then, well, just have the processes load those configurations off of the machines, right? Well, perhaps not, because as soon as you put it on a config file, then it's on the hard drive. And so if now you're relying on file permissions for the attacker to be able to get to it. And in my case, I was the web service, right? So if the web service itself can read its configuration file, then I, as logged in as the web service, could also read its configuration file. So the configuration file isn't it. Now I could perhaps encrypt the configuration files. And then when a web service starts up, have a command line argument that has the password to decrypt those, load those things into variables and things like that. But that's probably going to require some custom code in order to make that happen. You could write your own processes that fork other processes and so that it's a shared process to make something like that happen. But that's a complex process, and there aren't really good open source tools to do that at the moment. I'm thinking about something that I might be able to write to do that. One common way that we do store these environment variables in, if you will, in things is to use these .env files. .env files are very popular amongst web frameworks, right? Some people are saying, hey, these are commonly being used by various web frameworks and CI processes. So is there these .env files are out there? So are developers really using these? Well, if you ask Stack Overflow about them, yeah, they are commonly used. And actually, if you go out and you ask Google about them, then they are confused. So here's just a Google search. Google search, let's look for DB username, and the file type is :env. Google then says, okay, here's some websites that have env files on them. Here's one. The database name is this. The database username is this. The database password is this, right? And so, yeah. So you can obviously see that just putting things into configuration files is not going to be the solution, particularly when your file permissions don't prevent these configuration files from being delivered to search engines and attackers who might be looking for these env files. The other problem with env files is, well, you end up pushing those things to GitHub, right? So as soon as it becomes a file, you're the website developer and you are maintaining, as soon as it becomes a file that's on your file system, many developers will make the mistakes of pushing those things up to their GitHub pages. So I could show you similar Google dorks where you could go out to Google and look through GitHub to try and find environment variables. But I've got a couple more minutes that I want to show you a couple of other things rather than doing that, because anybody can do Google dorks. There's a bunch of interesting things that are out there now about using environment variables in order to hack systems. Right. So I just wanted to point you at a couple of these. There's this really good article on hacking environments with environment variables. In this article, what it's about is it's about the fact that different programs use environment variables to tell them how to work. And many of these different programs will look for scripts inside of environment variables and then run those scripts automatically. So what attackers can do is they can just create environment variables that point to their own malicious scripts. And then when you use a tool like Perl, then, well, their script is going to automatically run when you run the Perl commands. Or Python. Love Python, right? Or how about, let's see, Node.js, right? Many of these different applications have these different things, PHP and others, where by just creating environment variables, the attackers can point those applications to include their malicious payloads as ways of backdooring the systems. There's also privilege escalation attacks. So this LD preload. LD preload is a really powerful environment variable. And actually, very recently, let's see, on just June 22nd, Bruce Chenier posted an article talking about some Linux-based malware rootkit type functionality that is also using this LD preload environment variable. On Linux, we have the concept of shared libraries, just like you've got DLLs that sit in your System32 folder on Windows. We also have shared libraries on Linux. And when a process is launched, a child process, if it's using the same libraries as its parent process, rather than loading those into memory again, it'll just use the shared library, the one that was already loaded by its parent process. And since ultimately the parent process of all parent processes loads up a lot of these shared libraries, right, we only end up with one copy of those libraries in memory. Well, you can use this LD preload environment variable to change that behavior and to say, hey, I want you to launch, and I don't want you to use the default shared object library. I want you to use my library, and then you can specify that within this preload. So there's a couple of different cool attacks that are being used by attackers that are taking advantage of environment variables. There's also this other cool attack that was being used by this hacker named Mark Baggett. He tweeted about this on some time ago, November 2019. So if you're not following this Mark Baggett guy on Twitter, you should definitely do that. I really enjoy his tweets myself. So here's a little keylogger that you can do with just an environment variable. So, and I'm just going to demonstrate this. So let's say that I break into a box, or I've got my attacker box on the internet. So this while loop is going to be my attacker box. So let's see here. Let's do it here in this window. I'm going to launch my little while loop. All right, there's my attacker box. Okay, it's just sitting there waiting for commands. And I'm going to open up a new terminal here. And in this terminal, what I'm going to do is I'm going to set the prompt command. What I'm doing here is I'm setting the prompt command. Prompt command is a command that runs with every time you press enter and it generates a prompt, it runs the prompt command. So what it's going to do is when I press enter, it's going to run the command history-a, which says commit anything that I've done in history recently to the history file. Then it's going to tail the history file and just grab the last entry from the bash history file. And then it's going to send that to the attacker's IP address. So now with every command I run, every time I press enter, the commands that I type are recorded. So this is a keylogger. It's not an output logger, right? It's a keylogger, but there in just one environment variable, I can create a keylogger on your system. And that's, I think, pretty cool. Well, as an attacker, I think it's pretty cool. Okay. So there's something that you might find interesting. I don't remember why I put this into the slide because other than I thought it was cool to be able to, this was related to memory dumping, right? So now that we've talked about who can dump whose memory, you should be aware that you've got all kinds of sensitive things in your memory. So the fact that the only person that can dump memory is root, and the process, the person who launched the process can only launch their child processes and not sibling processes. Gives you some idea of the scope of these kinds of problems. But here, I use GitHub, right, all the time to push credentials. And many attackers do as well. If you look, or excuse me, many developers do as well. As you look on many different web pages, you'll see that attackers talking about, you can have Git remember your credentials and then automatically log you back in. And when you do a push or a pull, those things are actually stored in the memory of this process called git credential. And so here I'm just using sudo gcore to dump the memory of this particular process. I got the process number there. And then once I've dumped the memory, then I can just run strings on the memory. And here I'm just looking for my username. And there you can see the username and my GitHub credentials that are associated with the account that I was using when I did this testing. All right. And so with that, let's come to some conclusions. And I got one last thing I want to show you. Actually, let me show you this before I do my conclusions. So in SEC573, which is the upcoming Linux security class, we'll talk about things like this, like how to build environment variables and how to secure environment variables and those kind of things. And I just want to show you, I'm really excited about the lab environment that I've been developing for that class and the way that works. The color scheme on my screen here isn't the best for demoing this particular one, but I'm going to show it to you anyway. It's better when I don't have the white background, when I've got the one that I've designed for the virtual machine. But the way that this is going to work, it's going to be intensely hands-on. And this is just the environment variables lab from that system. You'll see that what it'll do is it's going to drop you into a Linux prompt. Down here, it's going to give you challenges like, all right, first run the env command to see all of the global variables. So I could type env, and when I run that command, it recognizes that I've done what I've said, or what it's told me to do, and then it's going on to moving on to the next challenge. Now, the challenges don't just tell you, here's a command to run. Each and every one of these challenges is like a mini little CTF. You can see that I got my check box down here that says you've completed that challenge. Each one of these is a little mini one-line command CTF. Now it says, okay, now echo, use echo to display that one that contain, or the one environment variable that contains your printed working directory. And so I'm like, all right, well, what is the environment variable that contains the current working directory? If I don't know that, I could do some research, look it up. It also supports hints. So if I do #hint, right, then down here it says, oh, okay, the name of that variable is PWD. So it's going to walk me through this. So now how do I echo that? Well, let's ask for another hint, right? And it says, all right, enter echo PWD, echo $PWD. So this is one of the very early labs where we're talking about these things. And you can see that it's going to have you do things like, now we're going to go through a couple of key environment variables and what they're used for. Like, what is the environment variable that stores your home variable? That one's called home, right? And then what is the environment variable that stores the list of directories that Linux searches through for commands? That's going to be the path, right? So let's echo the path. And this is actually up here. This is a full Linux prompt, so I can do whatever I wanted to in these commands. I can do all kinds of things. And then if I forget what it is that I was supposed to be working on, I can look down here, or I can also do a !? And it'll repeat the question again down there and show me what it was. All right, so now I got to create a variable name called myvar. How do I do that? Equals, and set it to 10. We'll do that. And then it says use the echo command to view the variable we just created. And then it says run env to see all the global variables, and notice that myvar isn't there. So env, it says it's hard to find that in that list of things to really know whether or not it's there. So let's grep for it. Env pipe grep myvar. Right? And so you can see the idea here is to give you these labs where you've got this step-by-step tutor that is both walking you through things and then presenting you with quiz questions such as now do this command and now do this command, and then giving you hints if you need those to walk through that. So it's intended to be a very hands-on lab. I would love it if to get it to the point where these labs are enough where you don't even need an instructor. But of course, I'd love to come and hang out with you for a week at any SANS class, either this one or my 573 class or 673 or one of the other classes that I've created. So yeah, I'll find some excuse for there to be an instructor in the room as Charlie and Don and I, other SANS instructors, are finishing up this course. But there's a little bit of preview of SEC 406. And with that, let's talk about our conclusions. There is lots of sensitive data that's being stored in our environment variables. There are some steps that you can take to reduce the risk of someone stealing them. Notice I didn't say to eliminate the risk of someone stealing them, but to reduce the risk of someone stealing them. Things you can do is you can exclude your environment variables from the history by putting a space in front of your commands whenever you set environment variables. You can not export those environment variables to sub-processes and instead have them use configuration files to load them up, right? If there's some way you can do it now, some of these steps, such as this one, aren't going to be available unless you are the developer who's writing the code, right? As the author of 573, where we teach you to write your own tools, these are the kinds of things that we need to know as developers that, well, if I don't rely on them exporting variables to me, then it's not going to be available to my sub-process, so that command injection isn't going to work. I can keep them out of the proc by having them loaded after the process loads. So I could store these in encrypted log files and then load them up. And of course, what I need to do to really make sure that they can't gain access to these things, even if I do all those things, I need to make sure that they don't gain access to root that's on this. And if you do all these steps, then maybe the API keys that you keep out there are going to be more secure. I can tell you that in the test that I had, where the organization was doing these things, it slowed me down, right? I couldn't just I couldn't just look at the proc directory and find those environment variables. It was interesting. It made it more difficult. Also, keep in mind that if you're using straight config files, encrypted config files, then that's not environment variables. So even the script that I wrote that dumped environment variables, it wouldn't work because they're not environment variables. Now, I would still be able to get to the configurations, but just by dumping memory and using strings like I showed you in this last slide here, where I was dumping the memory associated with that Git credential. Okay. All right. So that is that. Let me eliminate my slides here. Let's come back over here to StreamYard and see if I have any Slack questions over here. I know I've got some Inception here going on. Just looking for questions. I have to go now. All right. Let's see here. Looking at questions. Hello from DC. Hello, Seattle. Let's see. I don't see any questions. Do you recommend any books that explain now any geeks that don't have enough money, passion to dive into this major? The internet is such a great resource. I love the Inception. Oh, okay. Thanks, Stephen. No, I'm just kidding. Thank you for that. I could have stopped sharing my screen. That's what you did for me. Thank you. Yeah, just the internet is a great place to do these things and experimentation. If you can write little Python programs as proof of concepts to see, is this available? Is it not available? And come up with theories as to what you think might protect those environment variables, and then test them out. That's where all of this came from. And then, of course, reading the documentation as to why can't I dump environment variables? What access do I have to have in order to dump environment variables and things like that? All right, so I didn't see any other questions that were in here. Oh, Stephen even starred the questions for me. Stephen, who's running this stream, just took good care of me, and I appreciate his help. I appreciate the time of everyone who came to this session. I hope you found it useful. I hope that if you've got sensitive data in your environment variables, that now you've got some ideas as to things you might be able to do to make them more secure. And if you're on the offensive side, some tips and tricks that you might be able to use to, get around some of those controls. All right. Well, with that, thanks for having me on the show, and you guys have a great day.